Hello you guys, we are in chapter 9, section 2. We are going to look at a specific type of sequence in this section called arithmetic sequences. We're going to identify them to see if a specific sequence is an arithmetic sequence, and then we're going to find specific terms in the arithmetic sequence itself. Alright, so some vocab. An arithmetic sequence, what makes a sequence arithmetic is when the difference between consecutive terms is constant. So if we have a sequence and there's a pattern, but to get to each next term, it's not the same number that you're adding each time or subtracting each time, then it's not considered arithmetic. For a sequence to be arithmetic, then the difference between consecutive terms must be constant. And this constant difference is called the common difference. Alright, so let's identify if the patterns below are actually arithmetic sequences. So to identify one, we're going to look for the common difference between consecutive terms. And we're going to look to see if it has one, that is. So in this first example, we'll start with the second term and we'll go back to the first. And we'll say the difference between the second and the third term, so 6 minus 3, the difference here is 3. Going from the third term to the second term, the difference here, 9 minus 6. Here we go. 9 minus 6, the difference here is 3. And then going from our fourth term back to our third term, the difference between the fourth and the third term, 12 minus 9, is 3, and the difference from our fifth term to our fourth term, 15 minus 12, our difference is 3. So we see that our difference is constant, therefore yes, this is an arithmetic sequence, and our common difference here, our D, is going to be 3. And I should have mentioned above that common difference, our variable we can use to represent that is D. Alright, so you try. Go ahead, find the difference between each consecutive term. If that difference is constant, then yes, it's arithmetic, and determine what your common difference is. After you're done with these two you tries, go ahead and continue on. So you might want to pause right now. Alright, so finding values. So now, as you can see below, you're going to have a sequence. You're going to be told that it is an arithmetic sequence, and you want to find the terms in between. So if you know it's an arithmetic sequence, if the problem tells you that, then the first thing you're going to want to do is to identify the common difference. And then once you have that common difference, you're going to use it to determine your missing terms. Alright, so since it is an arithmetic sequence, then we know that we have a common difference that gets us from the second term to the first term, and the third to the second, and then this fourth back to the third. There's our common differences. So if I wanted to find those other terms, I need to determine what D is. Well, I know that if I go from 82, my fourth term, and I find the difference between that and my first term, that the difference here is a negative 18. And I know that negative 18 is made up of all the common differences in between, which, as you can see, were 3. 1, 2, 3. So I know negative 18 is equal to 3D. I don't know why I wrote negative. Sorry. Is equal to 3D. And to solve for D, we divide by 3. So D is negative 6. So I did my step 1. So this is my step 1. Identify the common difference. And now I'm going to go to step 2, and I'm going to use this common difference to identify my missing terms. So 100 minus 6 gives me 92. And then 92 minus 6 gives me 88. So my second and third terms are 92 and 88. Notice that I said 100 minus 6 because my common difference was negative. If my common difference here was a positive, then I would say 100 plus 6 to get me to my next term. So just keep that in mind. The only reason I subtracted is because D was negative. Otherwise, I would have added if D was positive. Alright, so you try. Find the second and third terms of the arithmetic sequence. 80, blank, blank, 125, and so on. Again, you might want to pause right here because I'm going to continue on with the notes. So arithmetic sequences are great because you can easily find the next term as long as you know what the common difference is. You just keep adding that number or you keep subtracting that number to continue on with your sequence and with your pattern. However, if you want to jump all the way, like for this example, all the way to the 100th term, then it might be kind of time consuming to continue adding your common difference all the way and to keep track of which term is which until you get to the 100th term. It might take a while. Even with a calculator, it's going to take a little bit of time. So we do have a sequence formula, an arithmetic sequence formula, and this is one of the formulas that you need to have memorized. So this is the formula for section 2 to know. So make sure you write this down. A sub n is going to represent the nth term, just like it did before. N represents the desired term or number of terms. So if you're trying to find the 10th term, it would be A sub 10, and N would represent 10. A represents, and this actually, you'll usually see it as A sub 1. So we'll put a little 1 right there, A sub 1. A sub 1 represents the first term. And D, as you already know, is your common difference. Alright, so step 1. We always want to identify what our common difference is, if possible. Without that, this will be difficult. And then step 2, we're just going to substitute in all the values into our formula. Alright, so it says, what is the 100th term? So I know right away n equals 100. It's our desired term. Of the arithmetic sequence, again, we need to make sure that it is an arithmetic sequence. Otherwise, we won't have a common difference. And so what is the 100th term of the arithmetic sequence that begins 6, 11, and so on? Well, so 6 is the first term, so I know A sub 1 is 6. And then to get from 6 to 11, or to find that difference there, 11 minus 6, I know that it's 5. So D equals 5. Alright, so now I'm just going to plug in everything. So A sub 100, our 100th term, is equal to our first term, 6, plus the quantity of n minus 1, n is 100, minus 1, times D, so times 5. And now I'm just going to go ahead and calculate this. So I have 6 plus parentheses first, so 100 minus 1 is 99. Close parentheses, and it's multiplying by 5. Then I'm going to multiply 99 and 5 together first. So A sub 100 is equal to 6 plus 495. And then adding those together, A sub 100 is equal to 501. So we did it. We found the 100th term in our sequence. The 100th term in our sequence is 501. Alright, so you try. What is the 70th term of the arithmetic sequence that begins 2, 8, ... Now is a good time again to pause it try this problem, and then we got one last part. Using arithmetic mean. So the arithmetic mean, I'm sure some of you already know that mean means average. So it's the average of the two numbers. It can be used to find a missing term between two known values in an arithmetic sequence. So for example, the arithmetic mean of the numbers 5 and 9, well, we would add them together, and to take an average, you divide it by 2. So 5 plus 9 is 14 over 2, and 14 over 2 is 7. So the arithmetic mean would be 7. So here's our example. What is the missing term of the arithmetic sequence? 15, comma, blank, comma, 59. So to find this missing term here, since I have two numbers, I can go ahead and say 15 plus 59, and then divide it by 2. So I get, what is that, 6474 over 2, and then when I divide, I get 37. So 37 would go right here. And then just to make sure that you do it right, that your math is right, you can always go back and see what that common difference was then. So 37 minus 15 gives me 22, and then 59 minus 37 gives me 22. And thankfully these numbers are the same because it's supposed to be an arithmetic sequence, and so your common difference should be. So that's kind of a way you could check yourself. Alright, so your last problem, I know it was a long video, I'm sorry, but hopefully it wasn't, too difficult. Find the 9th and 11th terms of the arithmetic sequence. Oh, I'm sorry. The 9th and 11th terms of an arithmetic sequence are 132 and 98. What is the 10th term? Alright, you guys finish up that problem, and then you're done. Thanks for watching.